Let us discuss whether a given function has a continuity or not on an interval. It says that a function can be continuous or not on an interval. This simply means that is continuous or not at every point on the interval. An interval is a set of real numbers between two given numbers, called the endpoints of the interval. Let's have some examples. The first one is that endpoints are not included on the interval. The interval is in between 1 and 6. In symbol, we have I equals open parenthesis 1 and 6 close parenthesis. The parenthesis is used to denote that an endpoint is not included on the interval. Next, endpoints are included on the interval. The interval is between 1 and 6, including 1 and 6. In symbol, we have I equals open bracket 1, then 6 close bracket. The bracket is used to denote that an endpoint is included on the interval. Next, endpoint at the right is included on the interval. The interval is between 1 and 6, including 6. In symbol, we have I equals open parenthesis 1, then 6 close bracket. Next, endpoint at the left is included on the interval. The interval is between 1 and 6, including 1. In symbol, we have I equals open bracket 1, then 6 close parenthesis. Next, endpoint at the left is not included on the interval. The interval is all real numbers greater than 1. In symbol, we have I equals open parenthesis 1, then positive infinity close parenthesis. Next, endpoint at the left is included on the interval. The interval is all real numbers greater than or equal to 1. In symbol, I equals open bracket 1, then positive infinity close parenthesis. Next, endpoint at the right is not included on the interval. The interval is all real numbers less than 0. In symbol, I equals open parenthesis negative infinity, then 0 close parenthesis. Next, endpoint at the right is included on the interval. The interval is all real numbers less than or equal to 0. In symbol, I equals open parenthesis negative infinity, then 0 close bracket. Using the graph at the left, determine if the function f is continuous on the following intervals. Let's have letter A. The interval is from -1 to 1. It's a check because the graph is continuous on this interval. Let's have letter B. The interval is from greater than -2 to 2. Another check because the graph is also continuous on this interval. Let's have letter C. The interval is from greater than -2 to less than 4. Wrong, because the graph has a hole at 3 before going to 4. Let's have letter D. The interval is from greater than -4 to less than -1. Another wrong, because the graph has a jump going to -1. Let's have letter E. The interval is from 0 to less than 3. A check, because the graph is continuous on this interval. Let's have letter F. The interval is from -2 to less than 3. Wrong, because the graph do not contain -2. Let us have different types of functions, where some have continuity on the interval and some do not have. Let's have the first one, polynomial functions. It says here that polynomial functions are continuous everywhere, meaning there are continuity on their intervals. Say f of x equals 1/2 of x plus 2. Using the table of values we have, if x is -4, then f of x is 0, because 1/2 of -4 is -2. Then -2 plus 2 equals 0. If x is -2, then f of x is 1, because 1/2 of -2 is -1. -1 plus 2 equals 1. If x is 0, then f of x is 2, because 1/2 of 0 is 0. 0 plus 2 equals 2. If x is 2, then f of x is 3, because 1/2 of 2 is 1. 1 plus 2 is 3. And if x is 4, then f of x equals 4, because 1/2 of 4 is 2. Then 2 plus 2 equals 4. If we are going to sketch the graph, we have a straight line extending in both directions. Let's have another polynomial function. Say f of x equals x squared minus 4. Using the table of values, we have if x is -2, then f of x is 0, because -2 squared is 4. 4 minus 4 equals 0. If x is -1, then f of x equals -3, because -1 squared is 1. 1 minus 4 is -3. If x is 0, then f of x equals -4, because 0 squared is 0. 0 minus 4 equals -4. If x is 1, then f of x equals -3, because 1 squared is 1. 1 minus 4 equals -3. If x is 2, then f of x equals 0, because 2 squared is 4. Then 4 minus 4 equals 0. If we are going to sketch the graph, we have a parabola, which is continuously going upward. Next type of function is the absolute value function. It says that the absolute value function f of x equals the absolute value of x is continuous everywhere. Let's have the table of values. If x is -2, then f of x equals 2, because the absolute value of -2 is 2. If x is -1, then f of x equals 1, because the absolute value of -1 is 1. If x is 0, then f of x is also 0 because the absolute value of 0 is 0. If x is 1, then f of x is 1 because the absolute value of 1 is equal to 1. If x is 2, then f of x is 2 because the absolute value of 2 is also 2. If we're going to sketch the graph of the absolute value function wherein f of x is equal to the absolute value of x, we have two arrows continuously pointing diagonally upward in opposite directions emanating from 0. Next type of function is the rational function. It says that rational functions are continuous on their respective domains. Let's have the table of values. If x is negative 2, then f of x is negative 1 half because 1 divided by negative 2 is negative 1 half. If x is negative 1, then f of x is negative 1 because 1 divided by negative 1 equals negative 1. If x is 0, then f of x is undefined because we have a denominator of 0. If x is 1, then f of x is 1 because 1 divided by 1 equals 1. If x is 2, then f of x is 1 half because 1 divided by 2 equals 1 half. If we're going to sketch the graph, we have two opposite curved lines. One is going downward from the left and the other is going upward from the right, moving closer and closer to 0 or to the y-axis but never intersecting it because 0 is not included on the interval. The last type of function is the square root function. It says here that the square root function f of x equals the square root of x is continuous on the interval 0 to positive infinity. Let's have the table of values. If x is 0, then f of x is 0 because the square root of 0 is 0. If x is 1, then f of x is 1 because the square root of 1 equals 1. If x is 4, then f of x is 2 because the square root of 4 is 2. If x is 9, then f of x is 3 because the square root of 9 is 3. And if x is 16, then f of x is 4 because the square root of 16 equals 4. If we are going to sketch the graph, we have a curved line starting from 0, moving or extending indefinitely upward to the right. Let's have another example of the square root function. Say f of x is equal to the square root of x plus 3. So therefore, f of x is equal to the square root of x plus 3 is continuous on the interval negative 3 to positive infinity. Let's have the table of values. If x is negative 3, then f of x is 0 because the square root of negative 3 plus 3 is equal to the square root of 0 and the square root of 0 is 0. If x is negative 2, then f of x is 1 because the square root of negative 2 plus 3 is equal to the square root of 1 and the square root of 1 equals 1. If x is 1, then f of x is 2 because the square root of 1 plus 3 is equal to the square root of 4, and the square root of 4 equals 2. If x is 6, then f of x is 3, because the square root of 6 plus 3 equals the square root of 9, and the square root of 9 equals 3. If x is 13, then f of x is 9, because the square root of 13 plus 3 equals the square root of 16, and the square root of 16 is equal to 4. And if we are going to sketch the graph, we have a curved line starting from -3, moving or extending indefinitely upward to the right.